All right, so we know that the space for up to 400 people is $700, and then the catering is that function. So if we want a total cost function, what would you do with that 700 and that 300 plus 32x? You would just add them together, and it would be 1,000 plus 32x. Now, some people were trying to do other things there. That's all you have to do. Just add them and you're done. All right, and then for the domain. So the domain, you just need to think logically. So there cannot be a negative number of people at this prom, so the smallest x value would be 0. What is the largest for this space? 400, good. Okay, so the 12 people on the student council are required to attend, but they don't pay for their ticket. So we have this new function in that gives the number of paying attendees if X students attend the prom. So what did you guys get for N? X minus 12, good. All right, is it possible for 11 people to attend the prom? No, because 12 people are required to go. What about 12, 20? 12 or 20. Is that possible? Yes. It'd be kind of sad, but it's possible. And so we need a reasonable domain for N. And so the least number of people would be 12. And the most number of people would be 400 still. Okay, and then 4 wants us to make a new expression where we write T of X that we got. That's the total cost for X number of people. And divide that by the paying attendance. Paying attendees. Do you guys know what this is? What that function gives you? What? It would be the cost per paying attendee. I don't know why I can't say that word. And it's basically the ideal ticket price to break even. So basically, when you buy a ticket, you just pay how much it costs for you to attend. And that's what you want to do for the prom. They don't want to make money on the prom. They just want to pay for everybody who goes and break even. Okay, and then for number 5, we want the domain of this new function. So there's still a maximum of 400 people that can go. But for this new function, can 12 people attend? What happens if this is a 12? What happens in the denominator? 0. We can't have that. So there, you can write this one of two ways. You can use a 12 but do a parentheses, or because I heard someone saying like a partial person can't go to the prom, so or you could say 13 to 400. It doesn't matter. I don't care. But you cannot include 12 for this situation. All right, now if you didn't really understand what 4 was, then you couldn't really do number 6, which is fine. X is the number of people. And so the student council wants to sell tickets for $40. $40 is not X. $40 is the ideal ticket price to break even. So we would take what we got for number 4 and we would set it equal to 40. And then we want to know how many total attendees they think are going to come to the prom. That means we want X. So we're going to solve this for X. So this isn't super easy to solve for X. What would you do? If something's in the denominator and you don't want it there, what do you do with it? Multiply by it. So I would multiply this by 40, which is going to be 40x minus 480, and that should equal the top. All right, and then to solve for x, I would get my x's together by moving over that 32x. And then, unless this freaks you out, I'm also going to move the 480 to the other side. That's kind of a lot to do in one step. And then when we divide by 8, that's going to be 185 people. Which would be nice. 185 people in a space that holds 400 people would be way better than what our prom is probably going to have. It's going to be like 500 people in a space that would hold about 250 people. Or probably not 500. It gets crowded. If you've never been to the prom, it gets super crowded. Okay, so on the back, we are going to fill in the notes. So the whole point of this lesson is to build functions from other functions. And so today we're going to talk about 4 operations we can use to create new functions. So functions can be added, subtracted, multiplied, or divided to create new functions. Alright, so one thing you are going to be asked to do is to find the domain of the new function. And so you have to just make sure it satisfies the domain of both functions you combined. So to determine the domain of the combined function, use values that satisfy, that doesn't say that, both domains. So if there is something that can't be included in one of your functions, it can't also be included in the combined, the new function. All right, and lastly, when dividing functions, make sure the denominator does not equal 0. Okay, so on first example, the number of customers at Pumpkin Pie Bakery, I like how pi is the number, is the Greek letter pi and not the real pie. That's okay. Depends on the price of the pie. Market research says that the number of customers can be estimated by C of P equals 110 minus 4.4 P, where P is the price of the pie. And so number 1A asks us to do a lot of things. We're just going to do it one at a time. So if the bakery charges $10 per pie, how many customers will there be? So we're just going to take that C and we're going to put 10 in for P. So that's going to be 110 minus 44, which is 66 customers. Right, and the second part says how much money or revenue will Pumpkin Pie Bakery make at that price if you assume each customer only buys one pie? So if each customer only buys one pie, how many pies are they going to sell? 66. And how much are they going to charge per pie? Yes. So that's going to be $660 in revenue. Alright, and then for B, we're going to write an equation for the revenue Pumpkin Pie Bakery will make if they charge P dollars per pie. And then we're going to do a reasonable domain. So think about how much you would pay for the most delicious pie in the world. Alright, so for the revenue, so we're going to call it R of P. We're going to do exactly what we just did. With this 66, that 66 came from the customer function. So that's 110 minus 4.4 P. All right, where did the 10 come from? What was the 10? The price of the pie, and in this case, the price of the pie is P. So that's the function for the revenue. And we could multiply that out if you wanted to, but I don't want to. Let's just leave it like this. Okay, so let's think about a reasonable domain. So they're not going to charge $0, I wouldn't think, but say that a pie is like 5 days old. How much would you pay for an old pie? What? $1? Okay. How much would you pay for the most delicious pie in the world? It's going to be more than $5. Because there you go. The most delicious pie in the world, somebody might pay $200 for. I don't know. I'd probably pay $50 for a delicious pie. Have you guys ever had Julia Bakery's fudge pie? It's the most delicious pie in the world. And I don't know how much they cost, but it's a lot. But it's worth it. Alright, so let's look at number 2. We have a function that is a graph. So f is this graph. And g is that table. And these aren't assigned to like pie prices or number of people. So when we go to do the domain, it doesn't have to do with like numbers of things. So it's just random functions. It does tell you that G has a domain of all real numbers. So it's defined by all real numbers. So underneath G, I'm going to put that. The domain of G is all real numbers. What about F? Do you guys see that little hole? Let me zoom in. Do you see the little hole on F? Alright, so that means that F is not defined there. It's like it's going along and all of a sudden there's nothing there and then it starts going again. So the domain of F is everything except 1. Because you do have arrows going up and arrows going in both directions, left and right. But there is no value right here. So its domain is everything except for 1. When x is 1. Okay, we'll come back to that in a second. So on A, we have this new function that is f of x times g of x. That's what h is. And we want to find h of 0. So this is going to be f of 0 times g of 0. and we've done this before, but some people might not be super comfortable with it. If we want to find f of 0 and we have a graph, we go to where x is 0 and find where that function is located on the y. So what do you think? What is f of 0? F of 0 isn't 0. Negative 1, okay. What about g of 0? When x is 0, what's g? Negative 8, right? Okay, so then f of 0 times g of 0 is just going to be 8. We just multiply those together. Right, and then we want to find the domain of h. So just like what we put up here in the notes, the domain of the combined function, we use the values that satisfy both domains. And so we just look at the domain of f and the domain of g, and we combine those. So what do you think the domain of h is going to be? Anything that's restricted from f or g has to be restricted from h. So what can x not be? 1, yeah. Maybe I said that weird. I think I probably did. Okay, and now see, we have to think a little bit. So we want to find all the values that h is going to be equal to 0. So when we multiply f of x times g of x, we get 0. So what do you have to multiply by to get 0? You have to multiply by 0 to get 0. So h of x equals 0 when either f of x equals 0 or g of x equals 0. All right, when does f of x equal 0? What x values make f of x equal to 0? There's 2 of them. They're zeros or x-intercepts. Negative 1 and 3. When is g of x equal to 0? What x value makes g of x equal to 0? Negative 3. Right here. Alright, so that's using graphical and tabular information for functions, and then the very last one we're going to use the algebraic form of the functions. Alright, so A wants us to take f and g and subtract them, and that's our new function. And so that's going to be the square root of 10 minus x minus 8x plus 7. Now you need to put 8x plus 7 in parentheses so you subtract the whole function. Now, is there any way I can combine anything? If I have this underneath a square root and stuff that isn't? No. So that's it. That's all we have to do is just write them beside each other and you're done. Except it does ask us to give the domain. Alright, so on this domain, we're thinking like we did yesterday with domain. And so there's 2 things that are going to restrict the domain, either a denominator or an even root. And we do have an even root. So we take the radicands, and what do we do with it? Not. You don't set it not equal to 0. Greater than or equal to 0. Very good. And then just solve it for x. Now, whenever I do this, I always keep the x on the left because that's how an answer choice will be if it's multiple choice. It's not wrong if you move it over to the right. Just be able to flip it around. But in this step right here, you need to divide by negative 1, which changes the greater than to a less than. Alright, and then on B, we want to find f of x divided by g of x. So that is just simply writing f of x on the top and g of x on the bottom. There's nothing else we can do here. Except give the domain. Okay, so we still have this square root issue. that we know the domain, part of the domain is going to be x is less than or equal to 10. Is there another issue? What's the other issue? We have this denominator also. So I'm going to move over here. The denominator cannot be equal to 0. So x cannot be equal to negative 7/8. All right, so what questions do you guys have? Super sleepy. Okay, we'll practice this tomorrow.